As I inquired last regarding the exam, it is offline probably, and it will be descriptive mode. Okay, I will share the slides now. Are you able to see the slides? Okay, welcome to week 7 tutorials of the NPTEL PMRF tutorial of course Pericyclic Reactions and Organic Photochemistry by Professor A. Shangaraman from IIT Madras. Myself, Anisha Suresh, PMRF TFO this course from IIT Bombay. Coming to question number 1 of this week 7 tutorials. So, the two step conversion of 7 dehydrocholesterol to vitamin D3 proceeds through. So this is given as 7 dehydrocholesterol and this is vitamin D3. So they are asking this is a two step conversion and what are the two steps that are taking place here. First one, a photochemical electrocyclic disrotatory ring opening and thermal andraficial 1,7 hydrogen shift. Second one, photochemical electrocyclic conrotatory ring opening and thermal andraficial 1,7 hydrogen shift. Then thermal electrocyclic conrotatory ring opening and photochemical supraficial 1,7 hydrogen shift. Thermal electrocyclic disrotatory ring opening and thermal supraficial 1,7 hydrogen shift. So what is taking place here? First a ring opening to should take place. Sorry. First a ring opening should take place uh, so that this six membered cycle will open and then a hydrogen shift will be taking place from this methyl group so as to get the structure. Okay, so this is a 4n plus 2 system. If photochemical ring opening is taking place, then the mechanism of ring opening should be 4n plus 2 delta will be disrotatory, that is thermal ring opening. If photochemical ring opening is taking place, it should be disrotatory. Okay, so we can rule out sorry, it should be conrotatory. So we can rule out these options and the right option will be this one. First a photochemical electrocyclic ring opening will be taking place followed by a 1,7 hydrogen shift and the hydrogen shift will be taking place in andrafacial manner. So this is the mechanism of 1,7 hydrogen shift. The chemical reaction involved in the above transformation can be illustrated as an electrocyclic reaction since there is a trans ring junction, so it is a photochemical conrotatory process. That could also be told. Since this is a trans ring junction, it is photochemical conrotatory process. And you can see this is the methyl group, so we can number from the methyl group: 1, 2, 3, 4, 5, 6, 7. A 1 7 hydrogen shift is taking place. So the hydrogen will shift to here, this double bond will shift here, this double bond will shift here, and this double bond will shift here, leading to the formation of an exocyclic double bond. So that is what is taking place here. And this 1 7 hydrogen shift is taking place in andrafacial manner. Okay. So the two-step conversion is, first step is the electrocyclic conrotatory ring opening. It is easy to tell, like, since the reaction is photochemical, as we can know, cis-trans isomerizations are have discussed regarding this. So it is a photochemical process. So 4n plus 2 photochemical, it is conrotatory according to Woodward-Hoffmann rules, and it follows a thermal andrafacial 1 7 hydrogen shift. So the right option will be option 2, where a photochemical electrocyclic conrotatory ring opening will take place, followed by a thermal andrafacial 1 7 hydrogen shift. Is it clear? Okay. Now coming to question number 2. In Paterno Buchi reaction, the major product formed is. So we have learned about Paterno Buchi reaction. So in that reaction, the major product formed is a cis adduct, a trans adduct, a racemic mixture, adduct formed from a long-lived diradical intermediate. So we can see the mechanism. So this is the Paterno Buchi reaction. A ketone is reacting with an alkene, leading to the formation of a oxetane ring. Oxetane ring means a four-membered ring containing an oxygen. Okay. So first radical will form here. It will combine with this. It will combine with this alkene, leading to the formation of two types of biradicals. If it is if the alkene is orienting in this fashion, if the alkene is orienting in this fashion, it will lead to formation of this biradical, and if it is orienting in this fashion, it will lead to formation of this biradical, right? So this is the more stable biradicals, because here benzyl radical is there and here a tertiary radical is there. Here this is less stable because of the presence of this primary radical. So this stable radical will be leading to the formation of the major product. So Paterno Buchi reaction is a photochemical reaction that involves addition of a carbonyl group to an alkene. It typically occurs when alkene reacts with a carbonyl compound when it is exposed to a UV light. Then the intermediate diradical formed during the reaction is short-lived, and its stability influences the overall reactivity and stereochemical outcome. So this intermediate diradical is short-lived. It will combine faster to give an oxytane ring. Then the stereochemistry is influenced by factors such as electronic properties of the reacting molecules, the stability of the radical intermediate, and the dynamic nature of the reaction. So the formation of a racemic mixture is a common outcome in photochemical reaction, highlighting the importance of considering stereoisomer formation in these processes. So what is forming in this reaction? A racemic mixture will be resulting from the Paterno Buchi reaction. Is it clear? If we are considering, here we have considered like a dimethyl group. If we consider like an ethyl group and a methyl group is there, even though this then we can consider this like an ethyl group, and this will be the radical. So if it is combining, it can have ROS conformation. This center will be chiral and it can have ROS conformation, and it will be of like a 50-50 chances. So it can lead to formation of racemic mixture. Okay. Now coming to question number 3. The major product M in the following reaction is. So what is the reaction that is taking place here? It's a name reaction. What is the reaction that is taking place here? We can see two vinyl groups are there, and in the product you can see there is a cyclopropane and a vinyl group. In all the options that have been given, there is a vinyl group and a cyclopropane ring. So what is the reaction that is taking place here? Okay, we can see it is a di-pi-methane rearrangement that is taking place here. So we have seen the mechanism like this. So this is our starting material. So when it is exposed to photochemical reaction condition, two radicals have been formed. So this can form radical and this bond can also form radical. Then these two radicals can combine, leading to formation of a cyclopropane ring. Now what will happen? This cyclopropane ring can undergo breakage. Right. It can break in this direction or it can break in this direction. So it is breaking in this direction, and this radical that will be forming, it can combine with this AR. This is also aromatic system that will combine to give a new cyclopropane ring, and this two radicals will combine, leading to formation of this styrene kind of system here. Okay, since the benzyl radical is stable, that is the reason why this is retained. The reaction follow di-pi-methane rearrangement. It is a photochemical reaction of a molecular entity that contains two pi system separated by a saturated carbon atom to form an ene substituted cyclopropane. It is specifically marino-diene rearrangement. So this is the mechanism that it will be following. So under photochemical condition, it will lead to formation of diradicals, as we can see here. Then out of which two of the radicals will combine, leading to formation of the cyclopropane. Then it can undergo, the cyclopropane can undergo ring opening from both sides. It can undergo a ring opening from this side or from this side. Since the benzyl radical is more stable, it will undergo breaking from this bond cleavage from this side, leading to formation of a benzyl radical. So here dibenzyl radical will be forming. Then this radical and this radical will combine, leading to formation of a new cyclopropane, and these two radicals will be combining, leading to a formation of a vinyl system like this styrene kind of system. Okay, is the mechanism clear? Okay, so out of the four, the right answer will be option 1. Okay, option 1 will be the right answer. Now coming to question number 4. Write the mechanism of the following reaction. So this is also an example of di-pi-methane rearrangement. We can see two vinyl systems here, cyclopropane attached to a vinyl. So this is also an example of di-pi-methane rearrangement. So now let us see what is the mechanisms that will be taking place here. So under photochemical condition, this will lead to formation of diradicals on both of these alkenes. Here also there is possibility, but it will be primary radical. Primary radical will not be that much stable. Then these can combine, leading to formation of cyclopropane. Then since this is a symmetrical system, the cyclopropane can open from both the sides, any of the sides. It can open from this side or it can open from this side. Both will be same. So CH3, one second. There is a slight mistake. This is a stable radical, right? Since it can isomerize with this double bond. So these radicals will combine, leading to formation of this cyclopropane. CH3, CH3, double bond, CH2. Now, since it is symmetrical, it can open from both the sides. It will be equal. So we will be considering one of the sides. Double bond. CH3. CH3. So these will combine, giving to formation of the new cyclopropane, and this will combine, leading to the formation of double bond. CH2 double bond. Clear? So this is the mechanism that will be taking place. Since these radicals, since these radicals, it can undergo a resonance with this double bond. It will be stabler. That is why it is not combining at this instant, and these two radicals are getting combined. Okay. Is the mechanism clear? Okay. Now coming to question number 5. A reaction of ketones and alkenes in the presence of light to form oxytenes is known as option 1 Norrish type 1 reaction, option 2 Paterno Buchi reaction, option 3 Diels-Alder reaction, option 4 Norrish type 2 reaction. Yes, it is Paterno Buchi reaction. So ketones and alkenes will react, leading to formation of radicals, and it will combine, leading to formation of oxytenes. So that is known as Paterno Buchi reaction. So this is the general mechanism of Paterno Buchi reaction. So we have a ketone under irradiation with light. It will lead to formation of diradical like this. And in the presence of an alkene, this diradical will combine with the alkene, leading to formation of the stable biradical, and that biradical will combine, leading to formation of oxytene. So the correct answer for our question will be option 2, that is Paterno Buchi reaction. Now coming to question number 6. The major product in the following reaction is. So what sort of reaction will be taking place here? So we have a ketone in the presence of photochemical condition, or in the presence of light, it will undergo transformation and it will give one of these four products. So what is a reaction and what will be the product? Yeah, it will be Norrish type 2 kind of reaction. So the diradical that will be forming at the ketone, it will be abstracting the gamma hydrogen proton, leading to further reactions. So we can see In this reaction, photolysis of the CO bond occurs, followed by removal of gamma hydrogen and then cyclization. So we can see here, this is the ketone. So this will be alpha position, this will be beta position, and this will be gamma position. And in the gamma position, we can see there is a hydrogen that is abstractable. So this will lead to formation of diradical when we are exposing it to light. So we will get this right diradical. Then this oxygen will abstract this hydrogen atom, leading to formation of a radical here. Then that radical and this radical that is present next to the carbonyl, they will combine, leading to formation of this four membered ring. Okay. Okay. Now coming to question 7. Complete the following Norrish type 1 reaction. So in Norrish type 1, alpha cleavage will be taking place, right? When the ketone is exposed to photochemical condition, alpha cleavage will be taking place in Norrish type 1 reaction conditions. So what will be happening? So in Norrish type 1 condition, alpha cleavage will be taking place. So here a radical will be formed and a tertiary radical will be formed here. Right. Now what will happen? It will follow with secondary processes. Secondary processes can be, first decarbonylation can take place. If decarbonylation is taking place, this bond will cleave, leading to formation of this radical and elimination of CO gas. Then this radical that is formed after the decarbonylation and the radical that was present after the alpha cleavage, they will combine. Okay, these are identical radicals, they will combine, leading to formation of the product. So this is the product that is formed after the Norrish type 1 reaction. Is it clear? Since this is identical, the product that we are getting is of 100% yield, or symmetrical. Since the system is symmetrical system, because of that we are getting 100% yield of this product. Otherwise there can be recombination between these radicals, so the yield can vary. Now coming to the next question. Identify A and B in the reaction. So what sort of reaction will be taking place here? Is, will it be Norrish type 1 or Norrish type 2 kind of reactions? Yeah, Norrish type 1 reaction will be taking place. Since there is no gamma hydrogen that is present adjacent to the carbonyl group, so here Norrish type 1 reaction will be taking place, that is alpha fragmentation or alpha cleavage. So first what will happen? Sorry. This is our system, four membered ring, double bondo, CH3 pH. So what will happen? Alpha fragmentation can take place, leading to formation of this radical. Here there will be, one second. Now what will happen? This oxygen ring expansion will be taking place. This oxygen will insert with this radical. So this will lead to formation of radical here. One O radical, CH3 pH, double bond pH, CH3. Now this will combine, leading to formation of pH, CH3. Here anion will be there, CH3 pH. So it is in methanol. So this will get quenched by methanol, pH, CH3, double bond. So this methanol can attack from alpha or beta phase. So depending upon that, we will get OMe alpha or OMe beta. Okay, pH, CH3. So this is the mechanism that will be taking place. Is it clear? Okay. So first Norrish type 1 alpha cleavage will be taking place. Then the oxygen will insert with this radical. A sort of ring expansion will be taking place. So anion will be formed next to oxygen. One second. It will abstract proton, not Proton will be abstracted from the methanol, not methanol will be going and attacking. Since this is anion, it can abstract proton from the methanol. Okay. So from where the second product will be coming, before recombining, this can rotate. So the initial stereochemistry will not be retained. It can rotate and it will give the other stereochemistry as well. So initially it was like this. Now this can be pH and this can be CH3 as well. So one will be A and one will be B. Clear? Methanol proton will be abstracted by the anion. It is anion. Anion will be attracted towards the positive charge, electrophiles. So the methanol proton will be abstracted and we will get this. Here two hydrogens will be there. Okay, initially one hydrogen will be there. Is this clear? Okay. Now coming to question number 9. How is this reaction taking place? What sort of reaction will be this Norrish type 1 or Norrish type 2? Type 1, yes. So here we are having this butanone kind of system. So when it is exposed to photochemical condition, alpha fragmentation will be taking place. So it can either undergo fragmentation in this fashion or this fashion. So this side fragmentation is preferred because it will lead to formation of secondary radical. When this fragmentation is taking place, we will get primary radical. So because of that, this is not preferred. Formation of secondary preferred over primary. So this fragmentation will take place. Then decarbonylation will take place, minus CO. Decarbonylation will take place leading to formation of this diradical, and that diradical will combine leading to formation of the cyclopropane ring, right? And in the second case, as we have seen in the previous example, alpha fragmentation will take place leading to formation of this. Then here diradical will form and that radical will combine with here an anion will be forming. And in the case of methanol, here proton abstraction only I think it will take place, because this is an negative charge. OMe formation will not be taking place, I guess. I will check into that again, okay? Because in question also that is there. I will check into it. Because since this is an anion from methanol, it can abstract only proton, right? This I will check into it and tell you in the next lecture. So, but how it is clear, right? How ring expansion is taking place and how ring contraction is taking place. That is clear, right? Okay. Now coming to next question. Complete the given reaction. So, what will be the reaction that is taking place here? It is type 2 reaction, right? Now we will see the mechanism. So here, okay. So this cyclopropane bond, it will be labile kind of. So that will lead to formation of the radicals first. So this radical will be forming, this bond will be breaking and it will be leading to formation of this radical. Now what will happen when this is recombining? Here a carbonyl group will be, when it is recombining, a carbonyl group will be generated. So this this bond will be migrating over here. So here 1, 2, 3, 4, 5. A 5-membered ring and 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7-membered ring will be resulting. Okay. This is not exactly type 2 kind of reaction, but it is not type 1 as well. First, this bond will be this cyclopropane bond, epoxide bond will be breaking, leading to formation of an oxygen radical and a secondary radical. Then when this oxygen radical is recombining, leading to formation of an ketone, this bond will be migrating over here, leading to formation of a 5-7 fused ring system like this. Okay. Now coming to the question number 11. Match the following starting compounds with corresponding products in the photochemical reactions. So in column 1, some starting materials have been given, and in column 2, some possible products have been given. So you have to match between what are the products corresponding to the starting materials that are given in column 1. Okay. Option 1. Okay. So we will see the mechanism for each of these reaction. So first one, what is the possibility? This is C. So here Norrish type 1 reaction will be taking place. So first alpha fragmentation will be taking place. Sorry, this is Norrish type 2 reaction, right? Norrish type 2 reaction is taking place in the first case. So alpha, beta, gamma, gamma hydrogen, this is gamma. Gamma hydrogen will be abstracted by the this ketone radicals, diradical that will be formed, O dot. So here it will be abstracting gamma hydrogen, leading to formation of 1, 2, 3, 4, 5, OH dot. 1, 2, 3. So this will recombine, leading to formation of four-membered ring. Here there will be, and this will be adjacent. Okay. So this will be a Norrish type 2 reaction. And in the second case, a Norrish type 1 of reaction will be taking place. So fragmentation will be taking place at this side. Then as we can see, a diradical will be formed. Then here abstraction will be taking place from this side. Alpha, beta, gamma. From gamma position, proton will be abstracted. Alpha, beta, gamma, alpha, beta, gamma. Alpha, beta, gamma, delta position. Here, this proton will be abstracted. This proton. Okay. Then here it will recombine, leading to formation of a double bond, and here an aldehyde will be forming. Is it clear? This will be Norrish type 2 and this will be Norrish type 1 reaction, and here a cis-trans isomerization will be taking place. Okay. Now coming to the last question. On irradiation using UV light that is greater than 300 nanometer, compounds X and Y predominantly undergo 1. X Norrish type 1 reaction and Y Norrish type 2 reaction. 2. X Norrish type 2 reaction and Y Norrish type 1 reaction. 3. Both X and Y Norrish type 1 reaction. 4. Both X and Y Norrish type 2 reaction. So what will be the right answer? Depending upon the stereochemistry, that is, if the substituent is alpha and beta, it varies, giving the Norrish type 1 and Norrish type 2 products. So which one will be giving Norrish type 1 reaction and which one will be giving Norrish type 2 reaction? We can get to it by seeing the proximity of the gamma hydrogen. Here is the gamma hydrogen approachable. No, no. Only one will be giving Norrish type 2 reaction. Here, since the equatorial, this hydrogen will be approachable to this oxygen radical, it can undergo Norrish type 1 type 2 reaction. However, in this case, since it is axial and this is not approachable by the axial hydrogen is not approachable by the oxygen radical, it cannot undergo Norrish type 2 reaction. So it will undergo Norrish type 1 reaction. Okay. So X will be undergoing Norrish type 2 reaction and Y will be undergoing Norrish type 1 reaction. It depends upon this. Here the hydrogen is easily approachable to the carbonyl oxygen. In case of X, since the hydrogen is easily approachable by the carbonyl oxygen, Norrish type 2 is possible. But in this case, the hydrogen is not approachable by the carbonyl oxygen. Because of that, Norrish type 2 is not possible. Hence, Norrish type 1 will take place here. So, the correct answer is option 2. Is this clear? Any doubts regarding any of the questions we discussed today? Okay. So we can meet next week for the last tutorial, followed by there will be a summary tutorial on next to next week. Thank you.